It's actually really nice to have people join in that I recognize names. All right, well, I'm going to go ahead and get started since I don't know how long this one's going to take, and I want to really try and keep these to no more than 45 minutes, not only for your sake, but for my sake too as well. So, because I'm not used to doing webinars yet. So, okay, so we're recording, and so you can always listen to this later as well. So welcome, everybody. This is the second OraPub Firefighting Friday, and the whole focus here is how to, not just me teaching, but actually demonstrating some of the things that I actually do. So real quick, who am I if you're not familiar with me? I'm a longtime Oracle DBA, and I specialize in Oracle performance and predictive analysis. I do a lot of performance research, and I post all of that on my blog, and I'm an author of a couple books, and I do a lot of conference speaking, teaching, mentoring, and I am also an Oracle ACE director. So that's enough about me. If you want to contact me, by far I would say the easiest way is to simply email me at craig@orapub.com. The other ways are not nearly as good. So about OraPub. OraPub is all about Oracle performance training, and DBAs is who I serve in my job. So I like to say OraPub is a one-stop location for specialized training in Oracle performance tuning. And if you've noticed my website, the front page has just recently changed over the last couple of days just to highlight the different types of training. So what you're experiencing today is obviously the webinars. And I think most of you on the call, at least the names I recognize, have actually done some of my online training as well. So, and that's going to keep happening over the years here. I'm on target to roll out a seminar once a month. And then, of course, I have my in-person training as well, which is not only public, but it's also, you can have me on site at your company as well. Okay, so here's the topic for today. Oh, and by the way, if you have any questions, go ahead and chat, and I'll try and answer those as best I can. So the topic for today, I didn't describe that real well in the one sentence explanation on the email, but essentially, I'm going to use ASH data and actually pull from the AWR table, DBA HIST active sesh history, to do an Oracle time-based like analysis. If you were on the last webinar, I did a time-based analysis based on an AWR report. This time, we're going to do something very similar. I mean, the objective is the same, coming up with a list of solutions, but we're going to use ASH data instead. And there's some clear advantages and disadvantages of that as well. And to do this, I'm going to use my BloodHound Toolkit, which is just, it's a nice little set of scripts that you can download for free off my website and use. And I'll show you that in some more detail. Ground rules. I'm going to try and keep this short, around 30 minutes, and ask me any questions you want to in the chat window, but keep in mind you are being recorded. All right. And of course, you can feel free to personally email me with any questions as well, and I'll do my best to answer you. The webinar will be online probably in about 2 to 3 hours after the webinar. I'm still figuring out the process, so it takes me a little bit longer than it probably should. And every tool that I use in the webinar, you can download for free off my website. In fact, I think I'm only using the BloodHound Toolkit today. And by the way, if you have a situation that you would like me to delve into and use in the seminars, feel free to email me that you have something for me to take a look at. But don't send me your AWR reports, and don't send me a bunch of data, okay, until we talked a little bit first. Okay, so here's the situation for today. So this is important to understand the situation. So overall performance is really bad. It's affecting all aspects of the application. So it's just not one particular user or one particular functional area. This is important for the type of analysis that we're going to do today, because if it was very application business focused specific, we would do some other things that I'm not going to do today. Okay, so that's important to understand. The situation predominantly occurs between 10 and 10:30 in the morning, and it's repeatable. You know, people just expect it to be really bad. The OS administrators swear everything looks good from their perspective, and the application user teams, they're getting really frustrated verbally. It's so bad. And the DBA team is kind of stuck in the middle. They just don't know where to start. And so that's where we're going to intervene and hopefully bring some stability to the whole situation. So the objective, The objective is we want to come up with a list of solutions that make sense, and we want to help people understand just what is going on. So the tools that I'm going to use is my BloodHound Toolkit, and we're going to use actually raw AWR data, and we're going to look at it just from that 10 to 10:30 time, and the date is August 1st. Okay. Now, before I actually, in a sense, get online and start running some scripts here, I need to give a little intro about a time-based analysis very quick, and then I need to talk about ASH for just a second to make sure that's really clear, the advantages of ASH and how we're going to use it. So an Oracle time-based analysis, basically, it groups together time in a way that's useful to us. And our objective typically is to reduce time. And the reason is because users experience performance in terms of time. So if our analysis is time-based, then if we work to reduce time from our analysis perspective, that should roll over and affect the user so they have a better experience. So while we're not going to focus on filling in these gray boxes, like you see these all over here, that's what we did last time. But we're going to do a time-based like analysis. So it's going to be similar to this, but we're going to use ASH data. So one other thing, another reason we break up and categorize the time here is that the solutions that we develop will typically point to one of the big areas of time. In other words, when we see big groups of time, that is like a performance opportunity or a performance improving opportunity kind of staring us in the face. And that's one of the big benefits of a time-based analysis. All right, let's talk about ASH for a second, particularly with the AWR reporting and all that. So the key AWR table, and by the way, I'll just say the key AWR table is going to be the snapshot table right here. Everything revolves around that. Okay, and the ASH data that's recorded goes into a DBA HIST table. Okay, and so you can see that it has a snap ID, it has a database ID, and an instance number, just like the DBA HIST snapshot table does. So that's the link. That's the foreign keys. But in addition to this, because it's ASH, right? It's ASH samples basically from $V session every second. We also have an ASH sample ID, an ASH sample time, and the session that was sampled along with its serial number. And then we have a bunch of other information that is essentially $V session type stuff. Okay. Now, I want you to understand the relationship between the AWR data and the ASH data. So I got a couple screens here I want to actually show you. Okay, so this is one way to look at this. So we have one AWR snap ID, okay, and that for each AWR snap ID, there's going to be multiple ASH sample IDs or ASH samples that take place, right? Because remember, ASH is sampling once a second, but an AWR snapshot typically might be once an hour. So within this 1 hour, there's going to be an hour's worth of ASH data that is going to be saved, pretty much. Okay, and within each ASH sample ID, of course, the active session information will be recorded. So what we're going to look at in this analysis I'm going to show you is that we're going to look at the ASH data, right, that was recorded in the AWR tables. Now, I just want to make sure I don't forget to say this, but while ASH samples by default once every second, only 1 out of every 10 session samples gets recorded in the ASH tables. Now, we won't be able to see this in today's webinar, but if you actually look at the time of the ASH sessions in the AWR tables, you can see that there's only 1 every 10 seconds. Okay. So the advantage of having all this ASH data is that we can get a lot of information in a small amount of space, but we miss out on the timing information, right? Like I can't tell you what the CPU utilization is. I can't tell you how long IOs take because those are time-based. But ASH, though, has other advantages that should become apparent as I go through this. Okay, if anybody has any questions or anything, just let me know. In fact, if anybody can hear me, can you just put something in the chat window? I want to make sure there's somebody actually out there. There we go. Got it. All right. Thank you, Roger. So fantastic. Thank you, guys. I wasn't sure if my computer locked up and I was talking to nobody for a second. Okay, so here's a really good example of this. You'll notice here on the far left, here's the AWR snap ID. So if you run an AWR report and you notice the beginning and ending snaps, that's what we're looking at. Okay, but within this one AWR snap ID, you can see there's multiple ASH sample IDs. You can see there's 1, 2, 3, 4 ASH sample IDs. So during this AWR snap ID, this ASH sample ID picked up 4 active Oracle sessions. Okay. Then when ASH sampled again, with this sample ID, there were 9 active sessions that were picked up. And then in this session, this ASH sample ID, there were 5 sessions picked up. Okay. So the other key thing is that, remember, every Oracle session is either on CPU or it's waiting. Okay, that's going to be really important for our analysis here. Okay, so with this information, with all this ASH information here, we can very easily get some really cool information. And I wanted to show you this because once I start using the toolkit, you're going to miss out on the underlying scripts a little bit, or the underlying SQL. And these SQL statements might not be syntactically correct, but what I'm trying to show you is correct. So I could say, give me a count of all the sessions that are recorded in our ASH data where the sessions are on CPU. In other words, they're active sessions and they're burning CPU at this time. Okay, I can get a count, really simple. And what's that count of? It would be, let's say this is the range of ASH sample IDs. If I said, give me all the sessions that are on CPU, the answer is going to be 1, 2, 3, 4. Okay, it's that simple. Okay, I can also say, in fact, in this case, I want to store from all the ASH data. I want to get a count of all the sessions, regardless of whether they're on CPU or they're waiting. And when I do that, now I can say, well, essentially give me a percentage of all the sessions that are on CPU. Now, this is really important to understand this one right here, what's going on, okay? I want to get a percentage of the sessions that are on CPU. They're related to all my ASH data that I have here. Okay, let's move on forward again. Now, what I want to do here is I want to get the count, right? In other words, if I look at all my ASH data for sessions that are on CPU, for each SQL ID, I want to get a count. In fact, what I should have done is I should have done a descending sort on count. And at the very top would be the SQL ID, where when I look at all my sessions, it was most likely to be burning CPU. So this is how you could find your top CPU consuming SQL statement, by looking at your ASH data. So it's very, very simple to do this. And then here's my last example is what I want to do here is I want to find the SQL ID that is related to DB file sequential read. So in other words, I'm looking at all the ASH data when the session state is waiting. And when it's waiting, the wait event is DB file sequential read. And then what I want to do is I want to list the SQL ID and get a count. So this is how I could find the SQL statement that is most likely when it's waiting on DB file sequential reads. All right, so this is, you can see it's really easy to do this kind of thing. But what's going to happen is you're going to end up with just a bunch of scripts. And so that's why I put the toolkit together. Okay. All right. So let's go ahead and get started. So to do this, I'm going to use my BloodHound Toolkit. I'm not going to go through the download process because I'm going to run out of time. I can already tell. So you just go to the tools part of my website, or you just do a search up here for BloodHound, and it'll bring you to the page. And it's real simple. You just click to download it, and I actually have the installation instructions. The installation instructions are right here. It's super simple to do. I mean, it's just a tar file, you XVF it, and you're ready to go. Okay, super simple. Okay, so let's go ahead now and start going through the analysis. So I'm logged on. Oh, before we set things up, I want to kind of outline how I'm going to set up the situation. So in the end, I want to have a summary of what's going on. I want to have a list of solutions. Okay, and I'm going to have some Oracle-focused solutions. I'm going to have some operating system-focused solutions, and I'm going to have some application-focused solutions as well. Okay, so I want to make sure that we do that. I'm looking at my notes here. All right. And then I'm also going to take a look, while I'm building up the solutions, we're going to take a look at Oracle. We're going to take a look at the application. And we're kind of going to take a look at the OS. But that's a problem with Awr Data, and that'll be highlighted once we get going. Okay, so let's get started. So I just logged onto my box here, and I have my environment variables set up. So I don't actually need to be where all the BloodHound scripts are. Okay, so I'm going to go SQL Plus. And this is where I have my AWR data. So this is important here, is that I need to go where my AWR data actually is. Okay, so BloodHound, to see the menu of scripts, it's BH menu. And, oh man, hold on. A little too big. Okay, I'm going to shrink the font down just slightly, guys. Hold on. There we go. That's better. Okay, so you can see that there is not very many scripts, and I did that on purpose because that's too much to remember, but the parameters you can enter in make these super flexible. All right, the first thing we need to do is we need to point to the AWR Awr data that we're going to do the reporting on. Once I set kind of the window of reporting, what I call the analysis window or the analysis scope, all the subsequent AWR Awr reports in my BloodHound Toolkit will reference that window of data. So it makes it real easy. So I'm going to start off by setting the scope. And so I use this BH set script. Okay, sometimes there's a lot of Awr data, so it's really nice to have parallel query going. I'm just going to set it to 5 because I have like 6 cores on this box. This is some minimum reporting thresholds. That just gets rid of some of the noise. I'm going to take the default. One of the things this toolkit can do, it can actually access remote data on another database, just not your local database. I'm not going to go through that right now, but essentially what it does is it takes the AWR data within your analysis scope and it pulls it from your remote database, potentially your production database, right? And it will pull that data into your local database. This way, when you do your analysis, you're not touching your production system. You're just touching the data that you pulled over onto your local box. I developed this specifically when working with clients where I just could not, keep messing on their production box. The data that I currently am going to use, it's already on this database. So I'm going to take the default here, which is local. Okay. Now, you can use any table you want, whether it's $$ active session history or it's the AWR Awr data, or it could be a copy of one of those. But I'm going to use the standard stuff, DBA hist active session history. Okay. And I can also, when I look at the data here, I can say, do I want a fixed window or kind of a relative window? If you're used to looking at $$ active session history, the Awr data there, you'll notice it makes a lot of sense if you can keep looking at like the last 15 minutes or the last 30 minutes. So it's kind of a shifting relative window. But when we're looking at AWR Awr data, typically it's a fixed window, like 10 o'clock to 10:30 in the morning, right? That kind of thing. And that's what we're going to do now. We want to look at a fixed window of data. And because it's fixed, I'm going to have to put the date in the time of the data I want to look at. So right now, it just looked at all the AWR data that I have. Okay. And I'm going to choose this database ID in instance 3. And I want to look at August 1st. And that's going to be 2014 at 10 a.m. And I have to type this, perfect. This is a free tool, so it doesn't do all the fancy validations and everything. Sorry about my voice here. Okay. It's just gathering information about that, setting up some stuff. So now all the future reporting that I do is going to reference this data. And so I'm all set. So now when I run all the scripts, I can just reference this data. Okay, so the first thing I want to do now is I want to get an overall kind of profile of the system. And I'm going to run the summary report, which is like a profile. Okay. And let's see. Oh, to do that, I think I give it a couple parameters. Here's my cheat sheet, right? Cheat sheet. Oh, yeah. I want to look at all the ASH rows. And this is going to make more sense later. So I'm just going to put a column in the ASH table here that I know where it just has to be a table, and I'm going to accept any value. So essentially I'm saying, select blah, 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 where flags is anything. So I'm not constricting my rows that I'm going to return, but I will use this to my advantage later. Okay, there's our profile. Now you'll notice if you're used to doing a time-based analysis, this is kind of set up for that. So we can see there's of all the, in fact, let me back up. Over this time frame right here, this 10 o'clock to 10:30, right, on August 1st, there were about 3,700 ASH samples. Okay, of those 3,700, ASH samples, if I look at them all, about 57% of those were burning CPU, and the remaining 43% they were waiting. They were not on CPU, and when they were waiting, 93% of the time it was an IO related wait event. And you'll say, well, okay, what's the wait events? Well, here's the top wait event right here. And clearly we can see from our wait samples about 82%, not about, 82.2%, 82.27% of all our wait samples have a wait event of DB file sequential read. So right away, we know a bunch about what's going on. Okay. So let's see this. Oh, first of all, in my summary, I'm going to put problem is overall slow performance 10 to 10:30. Okay. And let's see. And based upon what we see right here, there's opportunities to improve performance by focusing on reducing CPU and focusing on reducing the wait time. You can see it's kind of evenly matched right here. Okay. So I'm going to say there's opportunities here to improve performance by focusing on both CPU and wait time. Okay. So in my Oracle analysis right here, the CPU, we have about 57%. Okay. For the wait, that's going to be the remaining 43%. Okay. I want to line this up. And when we're waiting, IO is 93% of the time, and DB file sequential read is, of that 93% right there, that's actually going to be like 83%. Okay, so this gives us a really nice kind of a time-based analysis way of looking at the situation. We have opportunities to reduce both CPU consumption and the wait time. And if we're going to focus on the wait time, we need to focus on IO. In fact, it's IO reads, and the top wait event is clearly DB file sequential reads. Okay, so that's kind of an overall situation. Okay, now I'm going to drill down into the situation from both the CPU perspective, and then I'm going to drill down in a wait time perspective. Okay, so I'm going to look at my cheat sheet here. And what I'm going to do now, in fact, let me just paste this in, and then we can talk about it. See, it's pretty quick because our analysis scope is nice and tight. What I'm trying to do here is I want to find the top SQL ID that's related to CPU consumption. So in other words, this SQL ID right here, this is the one that when sessions are burning CPU, when SQL statements are burning CPU, this is the one right here. Now, it would be great if it was higher than 10%, but that's just what it is. Now, if you're looking at this, you're probably wondering, what is this blank SQL ID? Okay, I'm going to answer that later. I'm not going to let that go. It's just, it's too, I don't know how important it is, but it's something that everybody, including myself, wants to know about. Okay, so from a CPU perspective, okay, my top SQL statement is this guy right here. Okay, in fact, on the application, I know that from a CPU perspective, the SQL I want to look at is this guy right here, and that was about 10%. Okay. Now what I want to do is, now that I have my quote top CPU SQL statement, I want to profile that SQL statement. Okay. Now, how am I going to do that? Okay. Remember back when I did that summary. Like I profiled the entire system. Now I'm going to say, well, I want to profile just when the SQL ID is this value right here, and boom. Not too exciting. But look at it though. This SQL statement, it's all about CPU. In fact, according to the Awr data, there was not one occurrence where when this SQL state was running, it was tagged waiting. In other words, there was never a session that was waiting that was running a SQL statement. They were always on CPU. So this is clearly a CPU-focused SQL statement. Okay? Now, but still 10% isn't much, So maybe we can look at it from a different perspective. How about like maybe we can find a module or a module action or a machine or a client ID, something that is the big CPU consumer. Well, we can do that. It's really easy to do this with Awr Data. So I'm just going to give you one example right here. And let's look for the top module action. Okay, so I'm going to do this. It's real quick. So what we're looking at here is that I want to look at, in other words, show me the top module in action. And that's what gives me these two columns right here. Okay, and I don't want any other filtering. So I don't care what the sample ID, just give me all the rows. So we can see here that from a module perspective, it is clearly this, whatever this KPCSM module is, and that's the action on notify. But I'm just going to do the module, and that was about 12% right there. Okay, so from a CPU perspective, but if I'm looking at a module, okay, that's the module, and it was about, that's the percentage of CPU right there. And, when profiled 100% CPU, let's go ahead and profile this guy as well. So I can do that as well in Awr. It's super simple. I can do my summary when the module is that number right there, or that name. And boom, for this module, looking at all the Awr data between 10 and 10:30, okay, usually when this module was run, it was on CPU, right, about 95% of the time. When it is waiting, it's mostly I/O. But really, again, this is all about CPU. So it's about 95% of the time, this puppy is on CPU. In fact, remember, this is not time. This is samples. Right? Okay, so I just wanted to show you how easy it is to find the top CPU. SQL module, I could have kept doing this. In fact, I could have used any column here that's in DBA hist, active, SAS history. Any of these columns here, service hash, program, module, action, client ID, machine, it doesn't make any difference. I can do the same kind of thing that I did right here. I could say, no, I can do the same thing. Or I could say, yeah, I could put client ID right here, and it would give me the top client ID SQL consuming, right, client. I didn't say that very well. All right. Let's continue on. I think that's it for the CPU piece. Yeah, let's take a look at the weight now. Okay, we did the weight, so we know that's 43%. So there's some opportunity here. So to do that, I'm going to use another script, which is very, very similar. Okay. So what I'm going to do is I want to get the top SQL ID, and I don't care what the weight is or what the weight event is. So these are the top SQL IDs that we found when the session was active and it was waiting. And we don't care what the wait event is, so that's wildcarded right now. So again, we have that blank SQL ID, which is really irritating, right? But here's the top non-blank SQL ID, and that's about 5% of the time. So I'm just going to write this one down. That's it. I'm not going to look at all the other ones. Okay. Okay, and dang, what was the percentage there? 5.08, 5.08. And so let's profile that, right? I can do the same kind of thing I did before. We can profile this guy. So I can give me the summary when the SQL ID is this guy. And this gives me a profile. So you can see this SQL statement right here, the SQL ID, it's all about wait. And when it's waiting, it's all about IO. And you can see there's DB file sequential reads. Okay, which should be surprising. This shouldn't be surprising because our top wait event is DB file sequential reads. And this is the top wait related SQL statement. Okay. And so I'm going to put about 92% of samples waiting. I'll say like on wait. No, it's waiting. Okay. Now let's look at the module. You know, maybe we're not satisfied with this. Maybe we think we can kind of find, what to focus on the most. Maybe it's not just this one SQL statement. Maybe it's a particular module. So let's go ahead and see if we can find a module that has a lot of wait time associated with it. So let's see. Here's what I'm going to look at. No, not CPU. There's my wait right there. And I don't care what the wait event is. Okay. So this is the top module right here when we're waiting. Okay, and that's about 14%. Okay, so let me copy that. I say 14%. Yeah. And let's profile it. Do the same kind of thing we did before. Whoa. And this was the module, right? Boom, there we go. So again, this module is mostly about wait, but there is some CPU, related to it as well. And when it's waiting, the top wait event is going to be DB file sequential read. Okay, so this is about 34, 60, 67. 66. Waiting. Okay. So that's our top module. Okay. Okay. Let's see. Now, what I want to do is, let's see. Oh, yeah. Since we know the top wait event is DB file sequential read, why don't we just ask the question, what's the top SQL statement or what's the top module when the wait event is DB file sequential read? And that's really easy to do as well. So what I'm going to do here, I'm going to say, give me the top SQL ID when the wait event is my DB file sequential read. Oh, I don't want that. There we go. So DB file sequential read. Boom. And it shouldn't be a surprise. There it is. Okay. Now, again, it would be really nice if these top numbers were a lot larger, but this is just the data that I actually have right here. So that's the top SQL ID, but I think that is the same. In fact, I'm going to say SEQ. There we go. That's our top statement right there. Okay. So that's how you can find out, like if you have a particular SQL, if you have a particular wait event and you want to know what SQL statements are related to that wait event, you can do this same kind of thing. Okay. And this doesn't have to be SQL ID. I can say, well, what modules, what action, what client ID is associated with DB file sequential reads. You can ask all sorts of questions like that. Now, what I want to show you now is, remember, if I go back here, this happened on both the wait time and also on the CPU situation. We had a blank SQL ID right here. Now, you typically, I don't ever remember seeing that on an AWR report, but clearly it is in the Awr data. So, and we just can't ignore that. So I wondered what going on in Oracle could not have a SQL ID. Okay. Well, I actually checked a forum on this, and somebody said, well, it's PL SQL. Well, the problem with that is I've actually seen PL SQL with the SQL ID and a hash value. Okay. And I'm actually going to blog about this next week because I just recently did some more research on that. So that's probably not it. But how about a commit statement? See, a commit statement, there's no execution plan for a commit statement, right? It's even hard to explain, right? It just commits. We're not running a SQL statement, so there's no statement ID potentially. So from a wait event perspective then, what wait event is related to commits? Well, if you know Oracle well enough, the log file sync is the wait event related to a commit. When a session is committing and it's not burning CPU, the wait event will probably be log file sync. Okay, so let's do this. I'm gonna ask, give me the SQL ID where the event is log file sync. There you go. 100% of the time, when wait events were, when a session was waiting and the wait event was log file sync, the SQL ID in every occurrence, there's only 32, the SQL ID was blank. So for sure, one of the ways that we know that, for sure, one example of when a SQL ID can be blank is when the session is in the middle of committing and the wait event is a log file sync. So I thought that's kind of interesting to actually throw that in as well. Okay, let's get back to our analysis here. So that's kind of it, looking at kind of from an application perspective, a little bit from an Oracle perspective, and we haven't come up with our detailed solutions yet, so we need to do that as well. We're up about 40 minutes right now, so I want to finish up here pretty quick. From an OS, I always want to take a look at this, the CPU, the IO subsystem, network, and memory as well. Okay, I'll tell you right now, I'm not going to look at the network. Well, actually, we're not going to look at any of these. But if I think there's network problems, I'm going to talk to the network administrators. If it's memory, I can do some math and figure out the memory. And I can also talk to the OS administrators as well. CPU, I can figure out myself. But I can't get the CPU utilization looking at Awr data, because I can't get an entire box or database server perspective. To do that, I need to look at it from a time model perspective. And the view in question is $OS stat. And I'll probably have another webinar specifically about that. But I will tell you, though, that in this situation, the utilization was 27%, which means there's not a CPU bottleneck. If Oracle wanted to consume more CPU, it probably could. From an I/O perspective, again, what I like to look at is what is the I/O read times. Okay? But to do that, I need to get the average wait time for DB file sequential read. But see, Awr is not about time. It's about sampling. So I cannot get the average wait time from ASH wait events, or excuse me, from ASH data, unless ASH picks up time-based information for me. Okay, so this is why I want to actually look at like the wait event details, or why I look at an ASH report, $V system event, that kind of stuff, so I can figure out what the actual times are for a sequential read. And my rule of thumb is 10 milliseconds. Okay, that's kind of when it gets over 10 milliseconds, that's when I start getting concerned with sequential reads. And I'll just tell you that in this situation, it's easily below 10 milliseconds. Okay, so what this means from an operating system perspective, okay, there is not an OS bottleneck. Okay, there's plenty of resources. So what that means to me is if we can use them, let's use them. All right, so there's not an OS bottleneck right here. All right, so let's look at this let's try to come up with some solutions right here. Okay. So from an Oracle perspective, there's not a whole lot I can do specifically about CPU right now. Okay, from an Oracle perspective, all right. If it was a latching situation, there's parsing, things like that, then there's some things I can do. I can change some parameters to help Oracle be more efficient. But in this situation, because our top wait event is DB file sequential reads, right, then it's really, I need to focus on I/O. And what I really want to do is I want to reduce the likelihood of sessions. I should say I want to increase the likelihood of sessions finding blocks in the buffer cache. Okay, if I can do that, I will reduce the DB file sequential reads. So from an Oracle perspective, okay, I want to increase caching, okay, which means potentially bigger buffer cache using like the keep pool, cache tables, and any other fancy thing I could think of. Now, that doesn't mean these are great solutions, but these are possible solutions, and these are going directly at the pain point here of our wait time. Okay, so that's my big solution for Oracle in this quick little webinar right here. Okay, from the operating system, okay, there's no bottleneck. So don't do anything. Now, don't go to the OS administrators and complain that they're having some problems. Okay. From an application perspective, there are some things we can do here. Okay. We can tune SQL. Okay. And the SQL statements, the ones that I identified, which are, I wish they were bigger in terms of percentage. And there's our focus on CPU. And here's our one that we want to focus on wait time. But you guys get the idea. Okay. So those are the SQL statements that I want to focus on. And then I have a couple modules as well here. Okay. So we're going to tune SQL. And this one's about CPU. I got some application stuff I can take a look at. But again, I would like to have the percentages much higher. In fact, the way it was, I'll just put sequential reads here because we need to know that too. Okay. Hey, the other thing we can do, never forget this. While I can't get this in ASH, perhaps reduce the execution rates. For example, if I have a SQL statement that runs every second and that's just burning a bunch of CPU or doing a lot of sequential reads, maybe I can reduce that execution rate. So maybe it runs maybe once every 10 seconds instead of once every second, things like that. To do that, I really need to look at like $SQL stats, $SQL, that kind of thing. And I can also see that information just in a standard AWR report as well. But I can't get that from ASH, at least reliably. Okay. All right, so we have some solutions. We looked at the Oracle, the application, and we kind of look at the operating system, not real deeply or well. So let's see, we have opportunities to improve performance by focusing on the CPU and the wait time. There are Oracle solutions. That's the caching. And there are application, SQL, and module solutions as well. Okay. In fact, I'm going to do it like this. Okay. So we got some solutions, and there's our summary. Okay. So that's just a real quick example, and not only just on how to do an analysis like this, but also based on ASH data. Okay. In terms of using this BloodHound Toolkit, I think you can see it's really flexible, but I really just touched on the surface of this, because one of the things you can do with ASH is we can get down to the session level, which we can't do from an AWR report, right? Because it takes snapshots once every hour. With ASH, we have very granular time information. So we can not only get to the session level with ASH, we can, in a sense, develop a timeline of what a particular session was doing second by second. There's no way we can do that with an AWR report, but we can do that with ASH data. So this BloodHound Toolkit also has the ability to do that, as well as some visualizations as well. But I didn't want to touch on that. I just wanted to give a real quick high-level intro of the BloodHound Toolkit, doing something really practical using real Oracle data. So that is it for this. So let's see if I have any other closing comments. And then I don't think anybody's asked any questions. So if you have any questions, go ahead and type those in right now, and I'll answer those. And I will also stay on after we're officially over too. So, hey, I am looking for good scenarios. So if you have a situation AWR report or some ASH data that you want me to take a look at, let me know about that. Okay. And I will have the webinar online in a few hours, so you can tell your colleagues about that. And the next webinar, I will post that in a couple days. It's probably going to be 2 or 3 weeks from now. I'm not sure what the topic's going to be yet. And I will email notifications to everybody on the Firefighting Friday list as soon as I post the date. And if you have any questions or comments, please email me. All right. And that's it, guys. Okay. I do have a question. Hey, so this is officially the end. But I am going to take any questions you have, and I'll stay on here for like a half hour later if you have some questions for me. Thank you, Carl. I appreciate that. Let's see. Haresh had a question. Do you need the diagnostic pack to even query AWR tables? Hold on a sec. I just started coughing. Okay, do you need the diagnostic pack? You actually need to talk to your Oracle sales guy about that. I think the answer is, though, if you have the diagnostic pack license, then you can legally query the AWR tables. Okay, that's probably the best answer. Okay, any other questions? Haresh, thanks for asking that question. I was hoping somebody would ask that. So I'll be on for about another few minutes. Any other questions? Go ahead. Let's see. You got a question about if the issue lasts for 10 seconds, then. Yeah, that's a really good question. If the issue lasts for less than 10 seconds, there's a possibility that it will not be even available to look at in the AWR data. It will be, if it lasts for more than a second, it will be in the $V active session history. Okay. So yeah, that is a potential problem. If you have like a random situation that pops up that lasts for maybe just a couple seconds and it's super severe and then just disappears, you could actually not be able to even see what's going on looking at the AWR data. Now, there are ASH-related, I should say ASH/AWR instance parameters where you can increase the ASH sample rate. You can increase the rows that of ASH data that is actually saved to the AWR tables. See, the default now is 1 out of every 10, right? Which means basically you get one you get one sample of an active session every 10 seconds. You can increase that. You can set that to 1, which basically means all your ASH data will be written to the AWR tables. I don't know anybody who's done any impact analysis on that, though. So you're going to want to test that. But my gut feeling, though, is that it's not going to be that significant if you go from maybe, 1 out of every 10 rows to saving 1 out of every 5 rows, something like that. But, you really have to test that. And I have not done that testing myself. It will also store more AWR data, right? So your AWR data will be larger because there's more ASH data. But you have a tremendous analysis, repository by storing all that ASH data. Great question. Great question. Yeah, so you're using $V active session history. Yeah, you can use the same toolkit. You just point to $V active session history instead of the DBA hist. And typically when you use active session history, you don't use a fixed window like I did. You're going to want to use like a sliding window, a relative window. Okay, and that's typically how you actually do that. You also want to be aware of how far back in time your ASH data is actually stored. Because remember, ASH data is stored in the shared pool before it's copied to the AWR tables. Great question, really good one. Are there any other questions? Anybody have a topic they want me to do a how-to webinar on next time? Let's see, David, you said yes. What is yes referring to? All right, well, let's see. Okay. Oh man, you guys are all starting to type here. Let's see. David said if you have a concern that you're going to lose data and want to copy it elsewhere, is there a documented how to do that? There is an export facility or capability or a script or tool that comes with Oracle, so you can in a sense export your AWR data and import it into another database. Okay, but it's not automated, but you could do that, and I highly recommend that. Either that, or you want to store you want to store months worth of your AWR data. I do, because you might want to look back in time and see, well, what was the situation like last quarter, something like that. Or for capacity planning information, you're going to want to know that kind of information. So there are tools to do that. And I know there's products that are available you can purchase to do that as well. Okay. If you just want to look at the ASH data, all you need to do though is grab the one ASH table. Okay. But if you want to look at all the other AWR tables, then you're going to want to grab everything. All right, I need to go back here, and Roger asked a question. Dang. You guys are really silent, and then everybody started typing at the same time. Let's see. Roger said, got that. Okay, that's more granular sampling. Oh, the question is, do I compare like the AWR time-based analysis like I did during the last webinar with the ASH analysis? And no, I don't, but you could. And the results should be the same if it's a general overall performance problem. See, one thing I haven't really talked about much is what a time-based analysis and an AWR report are great for is like when there's overall slow performance. Okay, but what your AWR report does not help you with is when you have a real intense short burst problem and then it just disappears and everybody's looking at each other going like, what happened? How did it start? It's like an impact analysis kind of a thing. Like, where did it all begin? You can't do that with an AWR report, but with ASH data, you can do that. And I haven't done any webinars or even blogged about that much, but that will be coming up. So you can do both, Roger, but typically you don't. Now, I'll tell you one reason I don't do both is because even if I'm looking at ASH data, I will do that profiling of the overall system. That is the script that I was running when I did the BH sum. And how did I do that? It's like the overall profile. Yeah, this guy right here. This, in a sense, gives me kind of a time-based analysis-like look at the system. But it's not based on time, it's based on samples, but it's pretty much apples to apples, though. So this is why I typically do not use an AWR report unless I have to, if I have ASH right here. But there's nothing wrong with using an AWR report, though. Just depends on the situation you're in. Okay, other questions? Oh, how about the R graphs, you guys? All right, it's going to be a couple weeks before I get to the graphs. Here's the first reason. One is I want to blog about how to actually install R, which I just posted a blog on that yesterday. The other thing is, next, I want people to know how to create histograms in R based on $V event histogram information, right? And then we'll actually get into like connected graphs. And that's when ASH, you can do some really cool stuff with ASH. So you can visibly see like deadlock type situations where you can see one session is holding up another session visually and based on ASH data. So I'm going to get there, but it's not quite there. But you asked just about R graphs in general. Yeah, I will do that, but I'm not going to do the deadlock stuff right away based on ASH. It's going to take a while before we're ready to do that. But yeah, I will start doing that. So thank you. I'll put that on the list there. Trace deadlock after the fact. Yeah, I'm not sure if that's a statement or a question. Let's see, baselines. I'm not sure what the question is on that. Oh, someone asked, can I elaborate on the time weighted? Is that really significant in ASH? Okay, honestly, I have not looked at the time-related columns that are in ASH, okay, because there are some time-related columns in there. The reason I haven't is because if I want to look at time-based activity, I typically go straight at the AWR tables. The other reason is that it's really easy for people to start combining the ASH sampling methodology with timing. And they're really different. So like, let me give you an example. What people can fall into, they can say that 50% of all the CPU time, or I should say like of all the Oracle sessions over this half-hour interval right here, 50% of the time they were burning CPU and 43% of the time they were waiting. That is not correct. It could be correct, but that's not what ASH tells us. ASH says out of all of our 3,700 samples, of those samples, 57% of those were on CPU, right? So you have to be really careful when you go from samples to time. And so when you start using the time information in the ASH tables, people have a tendency to start mixing those. And then they come up with just all sorts of just crazy scenarios and they make up stuff that just did not happen. So I typically separate them, massively. Okay. Now, that doesn't mean what I'm doing is, well, what that means is I'm probably missing some performance improving opportunities by doing that, though. Okay. But so bottom line is you need to make sure the information is correct that you're looking at, and don't mix sampling and timing information together. You got to be really careful about that. Okay, other question. Great questions, you guys. God, thanks for asking. Let's see. Can you use it in that second table with BloodHound? I don't know what David. I don't know what you meant by that. A second table. Oh, the second table. I think what you're referring to is Can I use this backed up ASH data? Yes, you can. In fact, I'll take a chance of losing stuff here, but in that BH set, see, I can point to active session history. I can point to the actual AWR data or a copy of it. And all I got to do is to get a copy of this. And then at this particular time in the script, I will actually type in the name of the table. Like it could be, AWR, ASH copy for August of 2014. And this is what I actually do. So I have a smaller subset of data. Now, just in case you're wondering, how do you make a copy like that? Well, I didn't want to get too much into this, but you guys are interested in, there's actually a script right here that will copy the data. So whatever your current reporting data is or your analysis is, that analysis scope, you can use this little script to make a copy of it. It'll create just a standard Oracle table, but then you can, in a sense, load that in to do your analysis. How I typically use that is if I'm looking at the production sites ASH data, they could have like multiple years worth of AWR data or ASH data. There's no way. It's going to take me forever to report off of that, right? So what I'll do is I'll set my analysis scope to maybe just 1 month, and then I'll save that, or I'll create a copy of just that 1 month of ASH data, and then I will reset my analysis scope using that copy data, and then I can zero in on 30 minutes, 5 minutes, whatever I need to do. Okay, I hope that answered the question. How about StatsPack? StatsPack does not have ASH. Or I should say, if you're using, let me back up a second. If you have standard edition Oracle, you don't have AWR and you don't have ASH. Okay, if you have standard edition, there is an ASH like tool you can download off the internet. I don't want to get into that, but just do do a Google search for ASH simulator, and and just take it from there. Okay. But your question was, the question is, how about StatsPack, right? Is StatsPack rock and roll? StatsPack is awesome. If you don't need AWR, don't buy it. Okay. But probably to use the ASH data, you're going to need to purchase the licenses so you can actually run AWR. So you might as well if you can. I hope that wasn't too confusing. Somebody installed Awr today. Awesome. Way to go, Tim. Okay, let's see. Randy question. Oh, future. Yeah, okay. Do I use Atom reports? No, I do not. I don't. I actually have a product called Story that does essentially the same thing, and I think better for Oracle Standard Edition. A couple of reasons why I don't use Atom. One is it's kind of like what can happen actually when you start using ASH. It'll give you answers, and you can be a complete idiot and not even understand what's going on, but you still come up with answers. So I like to know exactly why I'm doing something, not just how it relates to DB time or something like that. I want to know why it makes sense. And if you go through a time-based analysis type approach, you will know why a solution is important or why it will work, because you can tie it back to a big chunk of time. So I don't, I personally don't use it. There's more anyway, that's all I'll say about that. Okay. There's great guys that wrote that thing, and there's a lot of neat stuff in there, but I personally don't use it. Let's see. How does the BB visual commands do? What do they do? Okay, this is good. See, you guys want to go to the visual, don't you? These visual commands, what they do right here, they will create for you the code that you can copy and paste into R to create a visualization like a connected graph. It can also create the code necessary to paste into Mathematica to create the visualization as well. If you want to know more about that, there's a README file. Oh, I don't have that here listed. If you go here, I'll show you here. Oh, there's the README file. There you go. There's a big README file right here. It tells you how to use this. It gives you examples. I should have told you this at the very beginning. This is how did it all begin. This is the time step-by-step analysis. And then near the bottom here, visualizing what happened. And I tell you how to do that. I give you examples, the whole bit. I mean, it's pretty straightforward. And yes, it's very cool. All right. So thanks for asking. I will do a webinar on that for sure at some point. Okay. All right. Anybody have any other questions? We're going past an hour right now, so I'm going to need to cut this off pretty soon. But if there's a pressing question, please ask. Okay, I'll wait. Oh, here we go. Oh, thank you, Randy. Appreciate it. Thank you, Roger. Appreciate it. Appreciate you getting up in the morning like this. One more minute, guys, and then I'm going to shut down. Hey, if you're still there, please let me know how the audio and the visual was on the webinar as well. Okay, I would appreciate feedback on that. Okay, thank you, David. Thank you, Fernando. Appreciate it. Good. I'm happy about the audio and the visual. I'm very stoked about that. Okay, guys, 30 seconds. I'm going to cut off here. Tim, thanks for joining me from the UK. That's great. Does BloodHound create tables in the database? Yes, it can. That's why you don't want to do it on your production database typically. But David, one of the really cool things you can do with BloodHound, though, is you can pull data from a remote database. And it doesn't do it using DB links. If you want to take a look, just follow the scripts starting with the BH set. And if you follow that, you can figure out how I actually do it. In fact, David, if you're still with me here, you see these scripts right here? Like this is going to be remote DBA fixed. Take a look at this one, and that will tell, then you'll see how I pull the remote data. It's kind of sneaky, and it works really good. Okay, 30 seconds. Okay, guys, this is it. We're going to sign off. I want to thank you, everybody, for joining me for the webinar, and I will post the next one in just a few minutes. At the latest, by next Monday, it will be online. Thanks again. Have a fantastic weekend.